Hello and welcome to another video. My name is Taylor and the topic of today's lesson is the structural formulas of acids. Okay, let's start. We know from previous lessons that inorganic acids are composed of hydrogen and acid residue. The acid residue may be an ion containing a single element. For example, chlorine, bromine, iodine, or sulfur. Such acid is an anaerobic acid. An acid residue may include a group of atoms that also contain oxygen, for example, nitric, sulfuric, and phosphoric acid. Such acids are called oxyacids. We start by writing down the structural formulas of anaerobic acids, oxygen-free acids. Writing the structural formula of an oxygen-free acid is nothing more than connecting hydrogen with a bond to an acid residue atom. There will be many bonds as there are hydrogen atoms. Therefore, for hydrochloric acid, it will be one bond between hydrogen and chlorine atoms. So one line or one bond. In turn, in the case of, or example, hydrosulfuric acid, there are a total of two bonds, one from each hydrogen. As you see, writing the structural formula of an oxygen-free acid, an acid that does not contain oxygen in its molecule, is not that complicated. Now, let's move on to oxyacids. Let's write H2SO4, the sulfuric acid, first. We draw the structural formula, starting with writing down two hydrogen atoms. Then these hydrogen bonds are combined with oxygen, so we create HO. Oxygen is bonded to the central atom of the acid, in this case, sulfur. All we have to do is add the two missing oxides on the right side. And here, note, we connect these oxygens with sulfur by a double bond. Why? Because a reminder, every oxygen is divalent, so it must have two lines. On the left side, each oxygen has two lines because one line connects it with hydrogen and the other with sulfur. On the right side of sulfur, these two oxygens are lonely, so they combine only with sulfur. Therefore, it is a double bond. Now, everything is in order, so sulfur, which is a hexavalent in this acid, also has 6 bonds. Let's talk about sulfurous acid, H2SO3. The situation is similar. First, we draw two hydrogens. We connect each of them with a single bond to oxygen. Then we connect the oxygen, which are already connected to the hydrogen with bonds, to the sulfur atom. And finally, of course, there's the last oxygen, which would combine with sulfur with a double bond. Now the oxygen is happy because it has 2 bonds. The sulfur is also happy because it has 4 bonds. Thus, it is 4-valent. Now, it's time for nitric acid. The difference here is that we have 1 hydrogen, so there will be 1 HO connection to our central atom, nitrogen, which is 5-valent, meaning it has 5 total bonds. We write the structural formula of nitrous acid in the same way as before, remembering that nitrogen is trivalent, so it has a total of 3 bonds. Our biggest hero, H3PO4, phosphoric acid, is the biggest because it has as many as 3 hydrogens. But the principle of drawing its structural formula is exactly the same as in the case of the previously mentioned oxyacids. The only difference in this case of the acid is the notation of 3 HO groups. It is important to remember that phosphorus, the central atom, must have a total of 5 bonds because it's 5-valent. And that's all for today. Thank you so much for watching our lesson. I invite you to leave comments and subscribe to see the next episodes with new topics. Thanks again, and we'll see you in the next video of A Bowl of Chemistry Knowledge.